Thanks everyone for joining. Looking forward to taking you through the journey today of a high level overview of managing a machine learning model utilizing MLflow. So just a quick introduction about me. As Richie mentioned, I am a senior ML engineer at Emburse. I have a heavy DevOps SRE background. In particular, my background is heavy distributed systems. I started out in Hadoop, moved over to Apache Mesos, and the last several years been in Kubernetes. Love tech, love automation, love taking things and building them and breaking them, all that good stuff. So what I'm here to talk to you about today, obviously, is MLflow. We're going to go through, lots of components that, MLflow or that consists of inside the MLflow project. We're going to apply this to a use case that I have, and just go through the whole ML lifecycle using MLflow. So to start off, let's talk quickly about what is MLflow. So at a high level, MLflow is a Python library, an extremely powerful Python library. It assists with many of the different steps and pieces of the machine learning lifecycle. It consists of several components, but the main components that MLflow uses to provide these services is MLflow tracking, MLflow models, the model registry, and then also model serving. One of the other awesome things about MLflow is that it has lots of built-in integrations with a lot of tools that you're probably using today. So a lot of integrations with different machine learning frameworks. It's even got integrations with the latest versions with things like LangChain and OpenAI. It is extremely helpful as far as being able to collaborate with teammates and across organizations. It is open source, and with that, it also has a massive community. So why should we care about MLflow? Well, developing applications in the application lifecycle, it's hard, right? When you throw in machine learning into that application development, it's way harder. So MLflow is here to make your life easier. It makes a lot of this process much more simple. So I've already mentioned, MLflow tracking for your experimentation management, which we'll see here momentarily. Being able to reproduce and collaborate across your team, your organization. Also being able to, store models and also version those models and manage those. MLflow makes this very simple, gives you one location to manage all these different versions of models. MLflow also is used you can also use it for deploying your models. And I'll go through and kind of show how MLflow simplifies this and makes deployment process very simple. I've already mentioned it integrates with a lot of existing tools that you probably work with on a daily basis. But just to name a few there, you can see, like TensorFlow, PyTorch, scikit-learn, one of my favorites, XGBoost. So it's just got a lot of capabilities to help battle the ML lifecycle here that we see here. So this is a nice image provided by Abid at Data Camp that kind of shows the ML lifecycle and how complex and complicated things can be. So with that, let's talk about. So I mentioned that MLflow is a Python library. It consists of of two components: the MLflow module, which is the main module that you'll be dealing with when you train models. So anytime you want to invoke a training session, it creates what's called a run. So a run is the collection of parameters and metrics and different artifacts that are used when you train an actual model. So you start a run, it becomes active, and everything that is contained, all the files, parameters, metrics that's contained in that run can all be logged to MLflow as part of MLflow tracking. And the way you do this is very simple. You just use the start run function. And then you can, obviously there are points in time where you want to end a run so that you're not overlapping and overwriting. Um, and you use for that the end run, which we'll see here in a few moments. There's also the MLflow client. So this is a class that you can actually use to interface with the different components of MLflow. So if you need to create a new experiment or create a new model registry or interact with any of the components, MLflow provides the client class for that, which we'll see here in a few moments. So if you want to go along here in the notebook with me, fortunately for us, we do not have to pip install anything in this. All of the uh, libraries have already been provided to us. Actually, the only one I'm unsure of is maybe argparse. We may need to install that one if we can make it to MLflow projects. So just to save time, we'll move on from the pip install here. I do have this available also as a collab notebook. It looks like the workspaces are working just fine, so we're just gonna keep plugging along here. So here's our use case that we're actually going to take this through, kind of a project flow and go through the steps here of the managing an ML model. So we'll pretend here that we're an investment firm and we back startup companies. So we're going to train a model to try to guess or estimate the profit that a company could potentially have based on R&D spend, administration spend, marketing spend, and also the state that the startup will reside in. So we've decided to train a model here using XGBoost. This data is not real, by the way. So when you get started here in MLflow, the first thing you're going to do is import your MLflow library. You're going to actually set the tracking URI. So this tracking URI is very important. We are actually setting this tracking UI to an internal SQLite database. You can also use tracking URIs to connect to external MLflow servers. But here we're just going to be doing this locally. Here we're actually going to create a new experiment here called potential startups. So we're going through here. We can see that MLflow is doing its thing, running some upgrades, and it's finished. So just to validate here that it was created, you can run this cell and we can see that potential startups was created and we have a timestamp here. This next cell, it's not going to work from, you're not going to be able to make a connection to it here from the workspaces. If you're doing this locally, though, we can go ahead and run this command from like a command line, and it brings up an MLflow UI. So let's take a look at an MLflow UI as an example. So in here, we created a new project called Potential Startups, and I've actually already trained some models ahead of time so we can see what this looks like. So what we just did was we actually just came in here and created a new experiment. So all of these new models and things that we're going to train in this session are all going to be added underneath this project. So we'll come back to the MLflow UI more in a few moments. So let's talk about tracking our first model. So this is where it starts to get interesting. So here we have our data. We're creating our data set. We'll go ahead and create the data set. Okay. And then here we're going to actually, set our tracking URI. Hang on 1 second. I think I have sorry, I have the wrong notebook opened. The solutions notebook. Let me go back to, my apologies. Okay. Sorry about that, guys. I need to go back through and run this real quick. So go back and we'll create our first.
Oh, one useful thing you can try is on the error if you you can use the AI to guess what the problem is. So if you go to the end of the code block where the error is, and you can say fix at the end of the error.
This should be working though. I accidentally used the solution notebook to start. I'm not sure if that's throwing it off. It's also sending me like way to the bottom of the notebook.
Oh, okay. If you do run and restart the session, then that might help clear up.
Yeah.
Is the problem just that we've got two versions of MLflow running? Then you might have to restart the kernel. Then.
Yeah.
Sorry. Yeah. Run, then restart kernel. A third from bottom. I'm gonna try again. Apologies for the delay here. Hopefully it gives everyone a chance to catch up. If you've got any ideas of what might be going wrong, feel free to say in the chat as well. Oh, is it a package version issue? Did that look like? Which version of MLflow did you want to use?
281.
Yep, it's around 281.
And these files, should I just switch back to
Oh, one thing, maybe let's start a new copy and go from scratch. So if you do File and then, sorry, the File top menu and just make a copy, and then if there's any problems in the existing notebook, we're starting fresh. So make a copy and we're going from scratch. This is actually a good tip for anyone if you're running into some kind of versioning issues. Like it should be fine to solve any problems normally by resetting the kernel, but occasionally if you're having issues, you can just start from scratch with by making a copy. All right, let's run this and see what's going on.
my cell's going crazy here.
Actually, while you're figuring that out, there is a question from the audience
yeah, go ahead.
That I can answer. So Ali was asking just why is the MLflow UI taking ages to run? The MLflow user interface isn't directly supported from Workspace at the moment. The way Workspace runs, it doesn't allow you to start running GUIs on top of the existing web browser. That's a feature that might appear at some point in the future. At the moment, it's not supported. If you want to use the MLflow UI, you're going to have to either run it locally, or I believe you can have a separate MLflow server. Weston, I don't know whether you can comment more on how to get the UI running. I believe you're demoing that later, right?
Yeah, so I've showed it before. So there's just not really a way to connect here from the data camp workspace UI. If you were to run this locally and not, in a notebook locally on your machine, you would be able to open up the ports necessary to run the UI service there. It's just not able. We're just not something that we can support here with the data camp workspaces.
All right.
Yeah, so I think we're working here. We're moving along.
All right. Do you want to give a recap of just what's happened and where you're up to, and then carry on?
Yes. So apologies for that, guys. Ran the wrong notebook. But what we've done here is we've created our first experiment here, and we've created the potential startups. So now we're actually going to go back and begin training our first model and run our first training run. So here we've actually went in, created our data set. And now here we're going to log our first project. So we need to set our tracking. Set the tracking URI here, which is, I'm going to copy and paste this. So we're connecting to the local MLflow, which is running locally, and using the SQLite database. And here we're going to set our experiment to the potential startups experiment that we just created. So here you can see our experiment is actually going to log to potential startups. And this will be the local artifact location to where our artifacts will be logged, which you'll be able to see in the MLflow UI. So what I'm about to show you is a nice feature, and all of those integrations that I've talked about from other frameworks and common things that you might be using from day to day. There's a function out there called autolog. So this actually is very, very powerful integration with MLflow. So using autolog actually will automatically log all the default metrics and parameters, and also the model to MLflow without us having to actually go in and specify, okay, for this model, I want to, I want to log XYZ metrics as well as XYZ parameters. Autolog will actually do all of that for us. So there's a lot of integrated things out there already for that. So We'll see that here in just a moment. So we're going to go execute our first run, which is our start run function. And you'll see here, we now have an active run that's been started. And here, using MLflow XGBoost, we're actually going to set our auto log here just to say, okay, I want you to automatically log everything when we train our model. So I don't have to specify all the parameters. So here, we're going to actually train our model on our data set. And when we do this, MLflow is going to automatically handle logging everything for us. So we can see here, our model has been trained. And what I mean by auto log, so if we go back to our MLflow UI and we look at one of our training runs, you can see that with auto log, MLflow has automatically logged all of our parameters. So all of our default parameters that are included in XGBoost have all been logged, and all of our metrics that from that training run have automatically been logged for us as well. So with that, MLflow also logs our model for us, as well as any other files that might be included inside of our local directory, as well as, which we'll see here in a moment, when we do our evaluation step, it will also automatically take care of logging any other type of artifacts for us as well. So Autolog is very, very powerful. If you are using a framework that MLflow supports, I highly recommend using that just to save yourself a bit of time. So MLflow also has an evaluate function that will actually take you can actually use to evaluate your model against the data set, your data set. So here we're looking at our data set that we just created, and we're going to do an evaluation over the test set. So here we're actually loading our model that we just trained, and then we're going to use the MLflow evaluate model to actually run the default evaluators over it. So what this is going to do is actually log SHAP explainers, which if we go back over here to our MLflow UI, that's where these images are coming through. So another very powerful functionality that MLflow provides is the ability to help out with model evaluation. So our run is now completed. We've trained a model. We're going to go ahead and actually stop our run. Sorry, not stop. End our run. So this cell right here is just if you wanted to populate a few more training runs into your into MLflow so that you have more than one running. So we're going to go ahead and train a few more models using our MLflow model. And down here, we're going to set the evaluate function to automatic so that we can not only train our model, but also have MLflow evaluate our test set for us. So I'm going to go ahead. I'm just going to run this cell twice so that we have two additional models, two additional runs. Cool. So now that we have multiple models inside of our experiment, we actually want to go ahead and start collecting metrics and basically comparing the different metrics and different things to come up with our what we think is our best fit model, so we can move forward and continue with testing and deployment. Um, MLflow has a really easy way of retrieving all of our training runs and our data that you would see inside here. So all of these training runs, you can see all of these metrics and parameters that we've collected for all of these. So we want to compare those and come up with a best, quote unquote, best model that we can deploy and actually start looking at. So MLflow actually provides what's called a search runs. So we can actually search these runs based on an experiment, and we can actually output this into a pandas data frame. So just looking over our data frame, we can see here's all of the things now that we can go in and kind of evaluate on our own using pandas. So just to look at this from a pandas data frame, we can see here's our 3 training runs that we just ran, along with the run IDs of them, start times, end times, and here's all of our collected metrics and parameters. So what we're going to do now is we're actually going to sort these runs by our R2 score. And we're going to use this as our, what we call our quote unquote best metric. So whatever R2 score is the highest, that's the one that we're going to use to actually deploy and look at. So here's our run ID that with the highest R2 score. So down here, we're just going to print only the R2 score and the run ID just to make it a little bit easier for us to register. So metrics dot R2 score. I'm going to do run underscore ID. So obviously we didn't change any hyperparameters, so all of the metrics are identical, but we're going to go ahead and utilize this run ID. So now you can use MLflow to sort based on any metric that you want, whatever metric you think best fits your model. And then we're going to turn around and take based on the run ID, because the run ID is what actually is used as a unique identifier for how things were stored in MLflow so that it can be retrieved. So now we have 3 models trained. We've identified what our best model is. And now we want to start using it and making it available for further testing. So to actually, hand out to other people, then they can start using it and evaluating it. So now what we want to do is we actually want to register our model to MLflow, to the model registry, so that we can provide a centralized location so that, users can start using our model. And as we'll see here, so let's go ahead and we'll copy the run ID of the best run. Oh, I'm sorry. First, we're going to create a connection to, so we need to create a space inside of MLflow to actually store our initial metric. So for this, we're actually going to use the MLflow client class, because this will allow us to work with the MLflow model registry to create a model registry called startup models. This is where we will actually store and register our models so that other people can start utilizing them. So here we can see we've created a new container space called startup models. And now we can begin registering these models to startup models. So make a connection to MLflow, and now we're going to come back here. We're going to get the run ID from what we came up with our evaluation. So we'll take this run ID here, copy it, and then we're going to actually register this model or this run to our model registry under startup models. So when we go ahead and run that, we can see here that we actually now registered a model under startup models, and we are creating a new version of this model. So I want to point out really quickly how powerful this is, being able to version control your actual models. So instead of overriding, a model that exists, when you register a model to MLflow, it actually version controls it for you. There are kind of out of scope for this workshop, but what you can do here is you can actually add tags to these models outside of just versions. So tags that would be more meaningful for you. So if you wanted to tag things with, development, test, production, things of that nature, whatever makes sense to you, you can actually use that on top of the version just to make it a little more meaningful for you. So now that we've got a model registered to our model registry, now we can go back and we can actually use MLflow to actually load our model locally. So MLflow uses a model URI that consists of models, the name of the model, and then the version. And that will actually pull the model from the model registry and load it locally. So here we're going to create a connection to our MLflow server. And down here we can see that we're actually using our XGBoost flavor. And then we're also going to use the load model function to actually load the model directly out of our startup models here. And we're looking at version 1. So after we run this, we should see our model actually get loaded, and we're actually going to print the model so we can see the output there. Awesome. So our model is now loaded. We loaded version 1. So the model is loaded locally, and now we can actually send some data to that to get a prediction. Cool. So we actually have now successfully, up to this point, we have tracked our experiments. We have utilized the model registry to not only store models and register models, but also have provided a location, a centralized location where other users across the organization can actually, start to load models on their own and start toying around with data and start seeing the results. So I'll quickly want to point out that, we did this using the MLflow Python library, but MLflow actually also has a CLI where you can actually load models from that as well and use it as a server. So MLflow has the ability to run like a web server for you, where you can actually send predictions. And if you look inside of the files, I actually have a shell script that will handle this for us. But unfortunately, inside this workspace, we don't have a way to actually make that connection. But I wanted to point out that MLflow also has a CLI and a web server that you can actually do this as well. So I'm going to go through MLflow projects really quickly. I have a couple minutes left here. So MLflow projects is a way that really simplifies collaboration and reproducibility for if other users want to take your code and start training models and registering them to MLflow. Um, it's also a really nice way to be able to automate training runs. So MLflow does this with a simple YAML file called the ML project. And inside the ML project, we can see here that we specify things like our Python environment, different entry points. So we have the ability to actually run, multiple steps inside of a training run if we need to. The real power comes from being able to parameterize our training runs here. So with our MLflow project, what we're doing here is we actually have a training file, and we want to be able to pass in parameters for the estimators and the max depth hyperparameters, so that we can see, if different hyperparameters might give us different results or better results. And like I mentioned, this is also a really good way that we can share our project across the organization and allow other people to be able to reproduce and train just as if we were training. This is also really good for, if you want to set up automated pipelines for training as well. You can kick off a ton of these ML project jobs and, just change the parameters. So this is what our training file actually looks like. You can see in our ML project file, we have a command. This command is actually just a Python script called train.py. This is what our training script looks like. So everything that we've done so far to train a model, but in addition, we have a parser. And this parser looks for the parameters that we pass for the n estimators and the max depth. So when we get through creating our training set, here we start our run, and we actually pass in those parameters to the training set. Here's our evaluation step. So we can use MLflow projects to actually automate everything that we've done so far to train a model, but in addition, with additional parameters. So let's go ahead and see. I might need to add pip install argparse. Is that here? It's not. So let's add an additional cell here. Richie, how are we on time?
We're coming up just past 22, so we've got 5 minutes, maybe a little more to go through the code.
Perfect. Okay. And how do you add a code?
Oh, so if you hover in between two cells, if you click by add content and select Python.
There we go. Thank you. So let's we're going to pip install argparse here. So I'll leave this up for just a second more if anyone's following along to get that installed. So now we actually need to restart our kernel for this to take place. So go to File, or is it Run, and then Restart Kernel. So it's under Run, Restart Kernel. Okay, so now here's what it looks like to actually do run an MLflow project within Python code. So here we're importing MLflow. We're setting our tracking URI to, our local MLflow. Here's our run function to actually run the project for us. So we're specifying our entry point as main. We want it to run underneath our potential startups project. We're just going to go ahead and use the local environment manager instead of our Python env.yaml. And then here we're going to pass our n estimators as 20 and our max depth as 5. So we're going to actually modify the default hyperparameters here and now train the model. So we can see here that here's where our MLflow project is actually executing our command. So it's executing our command with an estimators 20, max depth of 5. It started a run ID of E477. Okay. There it's evaluating our model like we specified in our training file. It's testing the metrics, logging the explainers, and our run exceeded. So now we're going to just to validate that this worked and to, just take a look at this just to ensure that it works successfully. We're going to search the run again. So let's plug in our search runs function, and we set our experiment ID to the potential startups up here. And then we need to take the run ID from here that just completed, and we're going to copy and paste that into here just to see if we get any runs with this run ID. Okay, so our most recent run was with this run ID, so it worked successfully. Just for some thought, if you want to take automation a little bit further with MLflow projects, you could use tools like Dask Array and actually kick off, multiple training sessions at one time. Dask also has hyperparameter search, which I've used in the past. It's really great. So it will take care of, creating hyperparameters for you that you can then turn around and pass in parallel to MLflow projects to kick off, multiple training sessions at once. Yeah, and just wanted to point out that you can definitely do this and use ML projects in some sort of automated fashion with your, your favorite automation tool and train multiple models at one time. I actually include here a way that you guys can try this on your own. So we randomize some of the parameters here, and then you can actually use Dask to kick all of these off at once. So we can see here, here's our method, or our function for kicking off multiple training sessions in parallel. And then you can print the results, sort all the metrics, and then register your best model that you come up with to the model registry, and then go ahead and run a prediction. So I would love to. This was a lot in a very short time, so I'd love to open up to questions now, if that's okay, Richie.
All right, wonderful. Thank you, Weston. Yeah, that's very impressive. Like, they got through like a whole kind of workflow there in the time. All right, so if you've got any questions for Weston, please do ask in the chat. I see we've got a few questions already. Before we get to audience questions, I do have one question for you.
Yeah.
I'm curious about what point in the workflow you would introduce MLflow. Is it the case that you would just create your model first, just using the standard Python tools, scikit-learn, whatever, and then once you're done, you think, okay, now I need to start deploying. That's when I introduce MLflow, or do you need to introduce it right at the beginning?
So in my experience, I would introduce it right at the beginning. So MLflow is really powerful, and you don't always have to use every single component of MLflow. So, for example, I don't personally, I have in the past, I don't personally use like the model deployment right now, but I do take advantage of other components currently. We already have what we call or have as a model registry. Um, at our company. Um, but I would say you always want to have the ability to visualize all of your training runs. So I would say, as soon as possible from the beginning. There is a way that you can like go back and pre-populate, um, previous runs if you still have the data somewhere. But it's much more complicated and complex if you would have just started from the beginning.
Okay, so if you're trying to optimize it, you're trying different features, you're doing some hyperparameter tuning, you can do that all up front and just track the results right
Correct.
from the beginning.
Yeah,
Okay.
and as you saw, like the auto logging, how powerful that is. So that eliminated a ton of work, right? It just automatically logged all of the, metrics and parameters for me. I didn't have to specify, okay, I only want to log, the R2 score, for example. It just went ahead and handled all of that for me.
Yeah, very, very convenient stuff. All right, so next question comes from the audience. So this is from Christian. So does MLflow cover the whole of the MLOps lifecycle? Actually, for anyone who's not clear on like what the whole MLOps lifecycle is, Reese posted a link to some resources. In there, there's an infographic which nicely sort of lays out all the different steps in the MLOps lifecycle. But Weston, do you want to briefly describe like what's covered and are there any bits missing?
Yeah. So, like I mentioned, MLflow will handle, the, experimentation tracking. So that's the MLflow tracking component. It will, we saw that it's very helpful with like model evaluation. So it's got a couple, you can do your own evaluation of all of your training runs using like the search runs function. There's also a evaluate function that allows you to kind of, it makes evaluating models very simple with just a simple Python call. Model deployment, it handles model deployment, model versioning with the model registry. And then obviously like being able to reproduce results with the MLflow projects.
Excuse the background noise. There's I hope it's a fire alarm test. It's either a fire alarm test or I'm about to burn to death. One way or another. We'll hopefully make it through to the end of the webinar. Thank you for that. So next question comes from MD Aminal saying, what are the MLflow alternatives and why should you choose MLflow?
So I don't know of any alternatives that cover as much as MLflow. So I've evaluated another project out there that's actually really great called AimStack, but that does not handle like the model and artifact tracking. That's just more of like a visualization piece. So you can actually log metrics to AimStack, but it doesn't handle if the actual artifact side of the house. So you can't log and unless that's changed over the last 6 to 8 months. You can't track actual physical files with it. That's been my only other only other tool I've evaluated.
Okay, so there's actually a sort of related question on this. So it sounds like so Maddo's asking does that mean that MLflow is kind of the industry standard? From what it sounds like, there aren't many alternatives that are as fully featured that you've come across. So would you say that that's a fair statement then?
Yes, I would say it's very, very popular. And like I mentioned, it's got a huge community. There's a ton of resources out there where you can get connected with the community. If you just, you just do an MLflow search on LinkedIn, for example, and ton of groups, the MLflow actual, the group or like the organization itself posts constantly on LinkedIn. sharing information. So there's a really big community out there for it.
That's very nice. If you get stuck with anything, there's going to be someone there just to help you out with problems. All right. Next question from Sridhar. Sridhar asks, did the auto log feature you mentioned, is that going to automatically tune the hyperparameters, or
It
is
does
that
not.
something? No.
It
Okay.
does not. It just logs the parameters that were used for that particular training run.
Okay, so you're gonna have to figure out the hyperparameter tuning yourself, and then that's gonna
Yeah.
record the
So
results.
right. So for that, there's things out there like I mentioned, like Dask hyperparameter search. There's also I've not used it, RayTune. So I've seen a couple demos where you can integrate RayTune into MLflow very easily. So again, MLflow has so many integrations to it. So if there's a tool out there that you are utilizing, it's likely already integrated with MLflow.
Excellent. And so in this case, we're talking about using Dask or Ray for parallelization, so you can do different hyperparameters and do all those different things in parallel at the same time. So you're not waiting and doing them one after
Correct.
the other.
Yep.
Okay. All right. Excellent. So Aliu asks, what are the key components of MLflow? So I think you talked about them, but you just want to maybe go over like what are all the main components here?
Yeah. So in recent versions of MLflow, they've added multiple other components, but the four main components and like the four components that MLflow started with is MLflow tracking, MLflow models, the model registry, and then MLflow projects. I think you're on mute, Richie.
Sorry, I muted myself there just because there was background sound. If anyone sees flames appear behind me, by the way, just let me know in the chat, please. We've got a few questions about how does MLflow compare to other tools. So there's a few variations on a theme, like how does MLflow compare to pipelining tools like Airflow?
So you would actually take MLflow and integrate it into your training pipeline. So the code that I showed you, you would actually take that code, put it, in a Git repo somewhere in an S3 bucket somewhere, and then have your tool actually pull down those files locally and run them. So you actually would integrate this into your current. So I'm a heavy Argo user. So I use Argo CD for GitOps, and I also use Argo workflows for pipelines. So this would actually integrate, or Airflow. So this would actually integrate directly into your Airflow pipeline.
So they're complementary tools rather than being
Correct.
competitors in this
Yeah.
case. All right, I think we've got time for one or two more questions. Before we get to those, I just want to say we've got a lot of upcoming events that I think you're going to want to attend. So tomorrow we've got a session on getting started with Databricks, and since you're MLflow fans, you can use MLflow from inside Databricks. I'm not sure whether we're covering that tomorrow, but we've got Ari Kaplan and one of his colleagues from Databricks, like super senior people coming along to talk about how you get started with that. If you're into this sort of thing, then Databricks is probably a very useful skill to learn. On Thursday, we're talking about implementing AI responsibly. So we've got two people who do a lot of responsible AI in their organizations. It's going to be a great conversation. Please do come along for that. And then next week is Azure week. So on Tuesday and Wednesday, we've got sessions on getting started using Azure. So one's like just how to use Azure, and the other one is using GPT on Azure. So a lot of great sessions coming up. Please do come along to those. All right, back to questions then. Oh, I'd like Reece said at the start, you need to sign up for the Radar virtual conference, March 21st. Please do come along to that. All right, so a user only known as N, secretive name, says, how does MLflow handle custom metrics and custom ML models or functions?
Yeah, so you can actually, like I mentioned, you can go outside of auto logging and you can actually specify, which metrics you want to actually send to. So you start a training run, and then you can actually specify which metrics or what kind of metrics or values you want to actually log to MLflow. you can find that in the documentation fairly quickly. So you can log anything. If you just wanted to log, A, B, C, D, you can do that as well. So you can log anything to MLflow.
Okay,
Whatever your heart desires.
Sounds like it's pretty flexible if you want to go sort of deep into the weeds there.
Correct.
All right. Mohammed asks, can we perform data versioning using MLflow, or is it for model deployment and versioning?
So I'm not as familiar with this. So this is kind of a newer thing that MLflow has been doing in the later releases of it, is they're actually tracking data sets for you. I don't know if it has any versioning of the data sets though. I don't think you probably caught it when I was sharing the MLflow UI, but inside of like where it shows the parameters and the artifacts for a particular training run, you can actually see the data set there.
Okay, that's interesting because I think normally you'd have to use like a standalone tool like DVC or something like that to track the versions of your data. So it's interesting that you can have that in the same place as your model versioning.
Yeah, I'm unaware that if it does that or not.
All right. And finally, a question from Mada just about who needs to use this. So it feels like a machine learning engineer is a pretty clear yes. Are there any other different roles or maybe even teams within an organization that might want to make use of MLflow?
I would say everyone. I would say including your operations engineers or your DevOps engineers, for example, anyone. I don't necessarily know that you would want your C levels running this if they know Python, maybe. I would say anyone that needs to interact with with the model at all, right? You can always have your DevOps engineers in charge of deploying models. Your data scientists, maybe they're the ones that are just doing the experimentation and logging of the experiments. And then you've got your ML engineers that are responsible for like, okay, we now have hundreds of experiments. Let's pick a favorite model, and that's the one that we're going to tell the DevOps engineers to deploy. So I would say, depending on how your shop runs. So inside of a small company, maybe you're the only guy. Maybe you're the ML engineer and the data scientist and the ops guy. So I would say it's for everyone.
I think you did raise an interesting point there that once you start talking about data products, there is going to be some software involved. And so you're going to have like software engineers are necessarily going to be having to use some of the same tools as the data people or the machine learning people.
Right. And maybe it's, it's going to be a mobile app, right? And you want to integrate the model directly into the app. Maybe you have front end engineers that also need access to it as well. So I think for me, I wouldn't say it's just for one person or one person in particular. I would say it's anyone that needs access to the model. And that's the cool thing. That's the cool thing about MLflow, right? Is it's that centralized location for everything.
Fascinating stuff. All right. So on that note, I think we'll wrap up. Weston, it's been a real pleasure. That was really interesting stuff. And yeah, hopefully some people in the audience can be getting some models into production very soon after this.
Very cool.
Excellent. All right. Final reminder, if you've not registered for the Radar virtual conference, please do register now. It's going to be amazing. You've got 2 weeks left. Click on the QR code in the top left. All right. Thank you once again, Weston. Thank you to Reese for moderating. Thank you to everyone who asked a question. Thank you to everyone who showed up today. Well done for taking an hour to improve your mind slightly. And I hope to see you again in future sessions. All right. Thank you. Bye.